For a topical guide to this subject, see Outline of Natural Sciences. Natural science is a branch of science concerned with the description, prediction, and understanding of natural phenomena, based on observational and empirical evidence, validity, accuracy, and social mechanisms ensuring quality control, such as peer review and repeatability of findings, are amongst the criteria and methods used for this purpose. Natural science can be broken into two main branches: life science and physical science. Physical science is further broken down into branches, including physics, astronomy, chemistry, and earth science. All of these branches of natural science are divided into many further specialized branches, and each of these is known as a natural science. In Western society's analytic tradition, the empirical and especially natural sciences use tools from formal sciences, such as mathematics and logic, converting information about nature into measurements which can be explained as clear statements about the laws of nature. The social sciences also use such methods but rely more on qualitative research, so that they are sometimes called soft science. Whereas natural sciences, insofar as emphasizing quantifiable data produced, tested, and confirmed through the scientific method, are sometimes called hard science. Modern natural science succeeded more classical approaches to natural philosophy, usually traced to ancient Greece. Galileo, Descartes, Francis Bacon, and Newton debated the benefits of using approaches which were more mathematical and more experimental in a methodical way. Still, philosophical perspectives, conjectures, and presuppositions, often overlooked, remain requisite in natural science. Systematic data collection, including discovery science, succeed natural history, which emerged in the 16th century by describing and classifying plants, animals, minerals, and so on. Yet today, natural history suggests observational descriptions aimed at popular audiences. Criteria. Philosophers of science have suggested a number of criteria, including the Karl Popper's controversial falsifiability criterion, to help them differentiate scientific endeavors from non-scientific ones. Validity, accuracy, and social mechanisms ensuring quality control, such as peer review and repeatability of findings, are amongst the most respected criteria in present-day global scientific community. Branches of natural science. For a topical guide to this subject, see Outline of Natural Science # Branches of Natural Science. Biology. This field encompasses a set of disciplines that examines phenomena related to living organisms. The scale of study can range from subcomponent biophysics up to complex ecologies. Biology is concerned with the characteristics, classification and behaviors of organisms, as well as how species were formed and their interactions with each other and the environment. The biological fields of botany, zoology, and medicine date back to early periods of civilization, while microbiology was introduced in the 17th century with the invention of the microscope. However, it was not until the 19th century that biology became a unified science. Once scientists discovered commonalities between all living things, it was decided they were best studied as a whole. Some key developments in biology were the discovery of genetics, Darwin's theory of evolution through natural selection, the germ theory of disease, and the application of the techniques of chemistry and physics at the level of the cell or organic molecule. Modern biology is divided into subdisciplines by the type of organism and by the scale being studied. Molecular biology is the study of the fundamental chemistry of life, while cellular biology is the examination of the cell, the basic building block of all life. At a higher level, physiology looks at the internal structure of organism, while ecology looks at how various organisms interrelate. Chemistry constituting the scientific study of matter at the atomic and molecular scale. Chemistry deals primarily with collections of atoms, such as gases, molecules, crystals, and metals. The composition, statistical properties, transformations and reactions of these materials are studied. Chemistry also involves understanding the properties and interactions of individual atoms and molecules for use in larger-scale applications. Most chemical processes can be studied directly in a laboratory, using a series of techniques for manipulating materials, as well as an understanding of the underlying processes. Chemistry is often called the central science because of its role in connecting the other natural sciences. Early experiments in chemistry had their roots in the system of alchemy, a set of beliefs combining mysticism with physical experiments. The science of chemistry began to develop with the work of Robert Boyle, the discoverer of gas, and Antoine Lavoisier, who developed the theory of the conservation of mass. The discovery of the chemical elements and atomic theory began to systematize this science, and researchers developed a fundamental understanding of states of matter, ions, chemical bonds and chemical reactions. The success of this science led to a complementary chemical industry that now plays a significant role in the world economy. Physics embodies the study of the fundamental constituents of the universe, the forces and interactions they exert on one another, and the results produced by these interactions. In general, physics is regarded as the fundamental science, because all other natural sciences use and obey the principles and laws set down by the field. Physics relies heavily on mathematics as the logical framework for formulation and quantification of principles. The study of the principles of the universe has a long history and largely derives from direct observation and experimentation. The formulation of theories about the governing laws of the universe has been central to the study of physics from very early on, with philosophy gradually yielding to systematic, quantitative experimental testing and observation as the source of verification. Key historical developments in physics include Isaac Newton's theory of universal gravitation and classical mechanics, an understanding of electricity and its relation to magnetism, Einstein's theories of special and general relativity, the development of thermodynamics, and the quantum mechanical model of atomic and subatomic physics. The field of physics is extremely broad, and can include such diverse studies as quantum mechanics and theoretical physics, applied physics and optics. Modern physics is becoming increasingly specialized, where researchers tend to focus on a particular area rather than being universalists, like Isaac Newton, Albert Einstein and Lev Landau, who worked in multiple areas. Astronomy. This discipline is the science of celestial objects and phenomena that originate outside the Earth's atmosphere. It is concerned with the evolution, physics, chemistry, meteorology, and motion of celestial objects, as well as the formation and development of the universe. Astronomy includes the examination, study and modeling of stars, planets, comets, galaxies and the cosmos. Most of the information used by astronomers is gathered by remote observation, although some laboratory reproduction of celestial phenomena has been performed. While the origins of the study of celestial features and phenomena can be traced back to antiquity, the scientific methodology of this field began to develop in the middle of the 17th century. A key factor was Galileo's introduction of the telescope to examine the night sky in more detail. The mathematical treatment of astronomy began with Newton's development of celestial mechanics and the laws of gravitation, although it was triggered by earlier work of astronomers such as Kepler. By the 19th century, astronomy had developed into a formal science, with the introduction of instruments such as the spectroscope and photography, along with much improved telescopes and the creation of professional observatories. Earth science is an all-embracing term for the sciences related to the planet Earth, including geology, geophysics, hydrology, meteorology, physical geography, oceanography, and soil science. Although mining and precious stones have been human interests throughout the history of civilization, the development of the related sciences of economic geology and mineralogy did not occur until the 18th century. The study of the Earth, particularly paleontology, blossomed in the 19th century. The growth of other disciplines, such as geophysics, in the 20th century led to the development of the theory of plate tectonics in the 1960s, which has had a similar effect on the earth sciences as the theory of evolution had on biology. Earth sciences today are closely linked to petroleum and mineral resources, climate research and to environmental assessment and remediation. Atmospheric science, though sometimes considered in conjunction with the earth sciences, due to the independent development of its concepts, techniques and practices, and also the fact of it having a wide range of subdisciplines under its wing. The atmospheric science is also considered a separate branch of natural science. This field studies the characteristics of different layers of the atmosphere from ground level to the edge of the time. The time scale of study also varies from days to centuries. Sometimes the field also includes the study of climatic patterns on planets other than Earth. Oceanography, the serious study of oceans, began in the early to mid-20th century. As a field of natural science, it is relatively young, but stand-alone programs offer specializations in the subject, though some controversies remain as to the categorization of the field under earth sciences, interdisciplinary sciences, or as a separate field in its own right. Most modern workers in the field agree that it has matured to a state that it has its own paradigms and practices. As such, a big family of related studies spanning every aspect of the oceans is now classified under this field, interdisciplinary studies. The distinctions between the natural science disciplines are not always sharp, and they share a number of cross-discipline fields. Physics plays a significant role in the other natural sciences, as represented by astrophysics, geophysics, chemical physics and biophysics. Likewise, chemistry is represented by such fields as biochemistry, chemical biology, geochemistry and astrochemistry. A particular example of a scientific discipline that draws upon multiple natural sciences is environmental science. This field studies the interactions of physical, chemical, geological, and biological components of the environment, with a particular regard to the effect of human activities and the impact on biodiversity and sustainability. This science also draws upon expertise from other fields such as economics, law and social sciences. A comparable discipline is oceanography, as it draws upon a similar breadth of scientific disciplines. Oceanography is subcategorized into more specialized cross-disciplines, such as physical oceanography and marine biology. As the marine ecosystem is very large and diverse, marine biology is further divided into many subfields, including specializations in particular species. There are also a subset of cross-disciplinary fields which, by the nature of the problems that they address, have strong currents that run counter to specialization. Put another way, in some fields of integrative application, specialists in more than one field are a key part of most dialogue. Such integrative fields, for example, include nanoscience, astrobiology, and complex system informatics. Materials science. Materials science is a relatively new, interdisciplinary field which deals with the study of matter and the properties, as well as the discovery and design of new materials. Originally developed through the field of metallurgy, the study of the properties of materials and solids has now expanded into all materials. The field covers the chemistry, physics and engineering applications of materials including metals, ceramics, artificial polymers, and many others. The core of the field deals with relating structure of material with its properties. It is at the forefront of research in science and engineering. It is an important part of forensic engineering and failure analysis, the latter being the key to understanding, for example, the cause of various aviation accidents. Many of the most pressing scientific problems that are faced today are due to the limitations of the materials that are available and, as a result, breakthroughs in this field are likely to have a significant impact on the future of technology. The basis of materials science involves studying the structure of materials, and relating them to the properties. Once a materials scientist knows about this structure-property correlation, she can then go on to study the relative performance of a material in a certain application. The major determinants of the structure of a material and thus of its properties are its constituent chemical elements and the way in which it has been processed into its final form. These characteristics, taken together and related through the laws of thermodynamics and kinetics, govern a material's microstructure, and thus its properties.